Okay, so in this section, we are going to talk about piecewise functions. And piecewise functions are functions that have different rules that apply to different portions of the graph. So, for example, growing up, I can remember that my mom had a cell phone plan where it was, $100 for 1,000 minutes. And so it didn't matter if she talked for 300 minutes of, for the month, it was $100. If she talked for 950 minutes, it was $100. So there was one rule that applied to that first 1,000 minutes. Now, the rule changed when you went over the 1,000 minutes, because then it was, say, 10 cents a minute after that. So she would still have to pay the $100 for the first 1,000 minutes that she used. And then there was a new rule that applied after that. Now, I've also seen the same type of thing used in like electric bills. Some of the electric plans will have stuff like if you use in the first 1,000 kilowatt hours, you'll get charged 15 cents a kilowatt hour. And then between over 1,000 up to 2,000 kilowatt hours, you'll only be charged 15 cents or 13 cents a kilowatt hour. So you're still paying the 15 cents for the first 1,000, but then you're paying 13 cents a kilowatt hour for after that. And then anything over 2,000 kilowatt hours, you're going to pay 10 cents or whatever it is. And so that one is one that has different rules that apply to different portions. Okay. So the first one that we are going to look at is this function. And I'm going to go ahead and transfer it over to our my whiteboard here and get this written down. Now, when these are written up, you'll notice two things. One is you'll see the rules that happen. Then they're going to specify when these occur. Okay. So in this case, we have C of T is 20. If we are between, let me go ahead and switch screens here so you can see as I'm pointing. Okay. So here we've got our function is 20 if the value is between 0 and 60. So anything from 0 up to and including 60 is going to be flat answer 20. This is kind of like the cell phone one, where it doesn't matter if I use 300 minutes or if I use 500 minutes. It's all the same price. Now, the rule changes when we go over 60. So if they want us to find C of 40, the first thing is, where does 40 fit? Does this fit in the top rule or the bottom rule? Well, 40 is between 0 and 60. So therefore, I'm going to use the top rule. So this is 20. Period. Done. Okay. Now, they also ask us to find C of 80. Now, 80 is not between 0 and 60, so it's greater. So I'm going to be using this second rule. So we're going to put 20 plus 0.40 times 80 minus 60. Notice this one actually has a T in it where we're actually going to plug the number in. This one did not have a T for that. So we've got 20 plus 0.40 times 20. 20 plus 8. So 28. So there's our answer for that one. Okay. So again, it's all about looking at what is the value that they want us to plug in. Which rule does that apply to? Okay. Now, the next one that we're going to look at is graphing one of these. So I'm going to go ahead and get this set up for us. Okay. So we have got the function f of x is equal to 3 when x is less than or equal to -1, and we have its x minus 2 if x is greater than -1. Okay. Now, the first thing that I'm going to do, okay, is I'm going to pick, and I'm going to do these in a couple of colors. Okay. So I'm going to do this one in red. Okay. So I'm going to pick a couple of numbers prior to, because it's less than -1. So I'm going to do -3, -2, and -1. Now, all of them have an answer of 3. Okay, so that's simple enough. Now, here's where this is a little bit different. Okay, I know that the new rule takes over after -1, but it's not just on whole numbers. So I kind of need to know where this goes. So I'm actually going to pick up, I'm going to do this one, and I'm actually going to put that transition spot, that -1, and then I'll do 0, 1. I'm going to go ahead and do an extra 1 for this one, okay? Just to get another couple of values in here. And then I'm going to get ready to graph this here in just a second, okay? Now, if I plug in -1, -1 minus 2 is -3. 0 minus 2 is -2. 1 minus 2 is -1. 2 minus 2 is 0, okay? Now, here is the key to this, okay? Okay, right here on this spot, okay? This is the spot right here that I'm going to use open circles on my graph to dictate that stuff, okay? So, and then I'll show you how we're going to fix our graph once we're done. Okay. Okay. So I'm going to start, and again, I'm doing this all in color just so you can see the stuff. So at -3, I'm at 3. So I'm going to put a solid dot right there. At -2, I'm at 3. I'm going to put a solid dot. Now, this spot right here on the transition, at -1, I'm going to put an open circle. I know that's kind of hard to see, but these are all connected. Okay, so I'm going to connect this back going this way because we could have also picked -4, -5, -6, all of those. Okay, now using my other color, green, I've got -1 is supposed to be at -3. And again, I'm going to make an open circle for that. Okay. Now, that's the only spot that I have to do that at. At 0, I'm at -2. So I'm going to put a solid dot. At 1, I'm at -1. And at 2, I'm at 0. So I'm going to connect those. And then those are in a nice kind of straight line. So that's going to keep going. Now, again, I play connect because I picked whole numbers here, but you could have just as easily picked a half or 0.7 or anything like that to have plugged in. So I've got to play connect. Now, I'm not allowed to have those 2 open circles. So I go back to my rules. Whichever one of these has the equals to sign, in this case, it's the red, you're going to fill in that circle, okay? Because it does still need to be a function, okay? Does still need to be a function, which means everything needs to have valuation. So again, I use the open circles there to help me make sure that I've got my 2 chunks, but only one of them gets filled in. Now, sometimes when this happens, and I'm going to do completely separate example up over here. Okay, let me see if I can find another color that'll write for me. Okay, so completely separate example here. Sometimes you will get in a grid space that you'll have, you know, some dots like this, and this connects back this way. And then when you go to do the other one, it actually layers one right on top of it like this. Then it becomes one nice solid piece. It's not broken into 2 separate pieces like this one. The 2 pieces actually connect with each other. Sometimes that occurs as well, okay? So that is piecewise functions.